Students, now our topic is solving quadratic equation. Quadratic equation is an equation like this form. I think equation of this form is not unknown to you guys, because in your previous classes in class 7 and 8 you found this type of equation. Let me give an example. 3x square plus 7x plus 4 equals to 0. It's a very easy example. Maybe you already know how we can solve this equation. For this solution, we have to write like 3x square plus 3x plus 4x plus 4 equals to 0. That is, this middle term 7x, we break it by these two terms 3x and 4x, so that their product is the product of these two corner terms, first term and final term. If we multiply 3x square and 4, we will have 12x square, and if we multiply 3x and 4, we will have 12x square. This type of procedure we used to call it middle term breaking, and we will have a solution like this: 3x into x plus 1 plus 4 into x plus 1 equals to 0, and we will have x plus 1 into 3x plus 4 equals to 0, and that's giving us x equals to minus 1, and x will be for this 4 and 3 we will have minus 4 by 3. It's a very easy problem, and I think all of you can do these problems easily. But what in case we cannot break the middle term? Suppose x square minus 3x minus 1 equals to 0. We cannot break this middle term to have the product of x square and minus 1, that is minus x square. This 3x cannot be broken in these two terms, so that we can have this product. Actually, it seems like it cannot be broken, but really it can be, but we can't find it easily. So for this solution we'll go for another trick. Let's see the trick. X square minus 2 into x into, we have to make it 3x. So for make it 3x, we will write here 3 by 2. See, this 2 and 2, it will be cancelled, and then it will give us minus 3x. And for this 3 by 2, we will write a 3 by 2 whole square here, and we will take this minus 1 over here, so it will be plus 1, and this 3 by 2 whole square is extra here, so we have to write another 3 by 2 whole square here. So both sides are balanced, and there is no problem to write it. Now this you can write like x minus 3 by 2 whole square equals to 1 plus that 9 by 4. It's giving 4 4 plus 9, 13. Now we square rooting both sides. X minus 3 by 2 equals to plus minus square root of 13 divided by 2. So we have x equals to 3 by 2 plus minus square root of 13 by 2. That is giving x equals to 2 and 3 plus minus square root of 13. So for this plus we will have one value, one root, and minus we will have another root. So for x we are having two roots. X equals to 3 plus square root of 13 by 2 and 3 minus square root of 13 by 2. So though we could not solve this problem by middle term breaking, but it is not stopping us to solve it. And the trick we followed here, definitely we can follow the same trick for solving any such quadratic equation. Now let's try for that. So our general form, we write it again here, that is ax square plus bx plus c equals to 0. So we divide by a both sides. So it will be x square plus b by ax plus c by a equals to 0. Now x square plus 2 into x into, to make it b by twice a, we have to write this like b by twice a, b by ax. So 2 and 2 cancelled and it will be bx by a. And for this b by twice a to be meaningful, we have to write b by twice a whole square here, and this b by twice a whole square is extra, so we have to write it again here, b by twice a whole square, and we bring the c by a over here, that is c by a. Now this will be possible to write like x plus b by twice a whole square and b square by 4a square here minus c by a. Now x plus b by twice a equals to, we will give the square here, and 4a square, b square minus 4ac. Now we will square root the both sides, that is x plus b by twice a equals to plus minus square root of b square minus 4ac divided by 2a. Square rooting 4a square, we will have 2a. And now x equals to this b by 2a will go to that side, that is minus b by twice a plus minus square root b square minus 4ac divided by twice a. And now twice a minus b plus minus square root of b square minus 4ac. Here comes our general solution for the quadratic equation, that is x equals to minus b plus minus square root of b square minus 4ac divided by 2a. So for this plus minus, we will always have two different values for x, and if we see now some examples like 3x square minus 9x plus 2 equals to 0, or 4x square plus 2x minus 7 equals to 0. For these two equations, here a equals to 3, b equals to minus 9, and c equals to 2. Putting the values of a, b and c here, we can easily find the solution of these two quadratic equations. So now our conclusion is, for any quadratic equation we will always find two different roots. We will always find two different roots. Does it really look like this? No, it does not really look like this, that we will always find two different roots. See here, at any case, if we have such a value for a, b and c, that b square minus 4ac equals to 0, in that case we will have 0 here, and for this plus minus we will not get two different values. That is, two different values will be equal. So not necessarily a quadratic equation will give us two different values. Quadratic equation will give us two values, but two values are not necessarily different. So let's check a special case here to justify this. Suppose x square minus 4x plus 4 equals to 0, and we can write this like x minus 2 whole square equals to 0, and then x minus 2 equals to 0, giving us x equals to 2. Though this equation is a quadratic equation, but it is not giving us two different values. Now let's check it. See, this is a, this is b, and this is c. Put the values of a, b, c over here. That is, for b we have to write minus 4, that is minus 4 whole square, and for a we have to write 1, and for c we have to write plus 4, that is 4 square minus 4 into 1 into 4, that is equals to 0. 4 square minus 4 square equals to 0. So if the quadratic equation gives us one value, it is also a quadratic equation. Actually, this one value, we will call it two same values. It is not one value actually, it is not one root, it is two same roots. So it is not wrong to say that a quadratic equation will have two roots. Sometimes these two roots can be equal, but in other cases these two roots will always be different. I think that is all for your understanding of quadratic equation for class 9 and class 10, and in upper levels we will know more about this quadratic equation, or maybe in this level in your next classes. Thank you.